Concentration is a term you hear a lot in chemistry. It basically means how many grams or moles of something is dissolved in 1 decimeter cubed of a solution. The units are either grams per dm cubed or mole dm cubed. So if we have 5 grams dissolved in a dm cubed of solution, the concentration would be 5 grams per dm cubed. Or if we had 0.1 moles, then the concentration would be 0.1 moles per dm cubed. Moles equals concentration times volume in dm cubed. So say we have 30 cm cubed of sodium chloride in 1.8 mole dm cubed of solution. How many moles is that? Using the equation, do concentration, which is 1.81, times volume, so 30, but divide this by 1000 since we want the volume in dm cubed, and the answer is 0.054. Here's another question. Rearrange the equation, so volume equals moles over concentration, so that's 0.07 divided by 0.5, and the answer is 0.14 dm cubed. In this question, we're asked to calculate the mass. First, work out the moles, so the concentration times the volume in dm cubed, which gives us 0.16 moles of NaOH. You now need to use this equation to work out the mass. So moles times mR of NaOH, which is 40, gives us a mass of 6.4 grams.
8.5 divided by 5 gives us 1.7 moles per decimeter cubed. To get the grams per dm cubed, first work out the mass, which is the moles multiplied by the molecular mass, which is 98.1, and we get 833.85 grams. Divide this by the volume and we get 166.77 grams per dm cubed. Concentration multiplied by the volume in dm cubed and we get 0.024 moles. Again, concentration multiplied by the volume in dm cubed and we get 0.175 moles. Mass divided by the molecular mass and we get 1.6 moles. Divide this by the volume in dm cubed and we get 5.3 mole dm cubed. Again, mass divided by molecular mass gives us 4.1 moles. Divide this by the volume in dm cubed and we get 8.2 moles per dm cubed. Start off by writing the balance symbol equation, which is NaOH plus HCl giving you NaCl plus H2O. Next, we calculate the moles of NaOH, so concentration, which is 0.3, multiplied by the volume in dm cubed, and we get 0.0225. We can see that there is a 1-to-1 ratio between NaOH and HCl, so we also have 0.0255 moles of HCl. Finally, to get the concentration of HCl, we do moles divided by the volume in dm cubed, and we get 0.15 moles per decimeter cubed. Calculate the moles of calcium carbonate. So mass, which is 15, divided by the molecular mass, which is 100.1, gives us 0.15 moles. The ratio of the carbonate to the acid is 1:2, so we have double the number of moles of HCl. Divide this by the concentration of HCl, which is 0.3, and we get 1 dm cubed, which is the same as 1000 cm cubed. Convert grams per dm cubed to moles per dm cubed. You do this by dividing by the molecular mass. So 70 divided by 58.5, then multiply this by the volume in dm cubed, and we get 0.042 moles. Write down the balanced equation. Calculate the moles of HCl, which is 2.4 times 7.42 divided by 1000, and we get 0.0178 moles. The ratio is 2:1, so the moles of the carbonate is half that of the acid. Now calculate the molecular mass of the carbonate, which is 2.05 divided by the moles, and we get 230.3. Now to calculate the molecular mass of X2, we subtract the molecular mass of CO3 and we get 170.3. Divide this by 2 and we get 85.15, and this corresponds to rubidium. Write down the balanced equation. Now work out the moles of sulfuric acid and the moles of NaOH. It's half the amount since the ratio is 2:1. Calculate the concentration of NaOH, and to get it in grams per dm cubed, multiply by the molecular mass, and we get 0.92. Calculate the moles of NaOH and the moles of acid in 25 cm cubed, which is half the amount since the ratio is 1:2. Now calculate the moles of acid in 250 cm cubed. Now we calculate the molecular mass of the acid plus the water, which is the mass divided by the moles. Finally, to get the value for N, we subtract the molecular mass of the acid, which gives us 7.88, rounded off to 8. Write down the balanced equation, calculate the moles of HCl, calculate the moles of the carbonate in 1000 cm cubed, calculate the relative mass of the carbonate, and the mass of M, and the relative mass of the metal, which gives us 23.5, so it must be sodium.